Definitely technological object that maneuvers, broadcasts a signal or transmits some artificial light. The Hubble Space Telescope took a very high resolution image of it, and all we see is some glow.
3. I-Atlas shattered the physics of comets the moment its tail pointed straight at the sun. Instead of being pushed outward by solar wind like every comet in history, it fired in the opposite direction, expelling exhaust with precision.
Now, until recently, we haven't seen dust being pushed back behind the object by the solar radiation pressure.
What began as a faint rock suddenly burned red and yellow, and then shifted again into a neon green pulse that lined up with small but deliberate course changes. For astronomers, this wasn't strange. It was impossible, and impossibility in space is terrifying. The sudden color change.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
The first tail had already startled astronomers, but what came next forced even the most cautious scientists to admit that something was happening beyond normal comet physics.
This is the first time something like that is observed, where there is a glow ahead of the object towards the sun.
On September 7th, the James Webb Space Telescope trained its infrared instruments on 3I Atlas, looking to capture a sharper, deeper picture of the strange visitor. What Webb returned was shocking. The red and yellow glow that had spread from the object in earlier days was gone. In its place stretched a neon green plume, burning with a steady intensity and then pulsing rhythmically as though it were alive.
There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
This was not the faint green haze astronomers sometimes expect when comets pass near the sun. It was not a soft tint buried in the gases of a normal coma. Instead, the entire tail seemed to transform into a luminous emerald spear, a light so sharp and concentrated that it looked almost artificial. And what truly unsettled scientists was not only the color, but the way it behaved. Each pulse of green light coincided with a tiny but measurable change in the object's trajectory.
We'll pick out objects that are moving inside of the four frames, and we have to identify if they are real or if they are false detections.
As though the glow itself were somehow linked to controlled bursts of thrust. One camp of astronomers argued for chemistry. Comets often glow green, they reminded the public, because molecules like cyanogen or diatomic carbon become excited under ultraviolet radiation. When those gases are stripped of electrons by solar energy, they fluoresce in green wavelengths, and to see that color is not unusual in itself. Indeed, comets like Lovejoy and 46P/Wirtanen had put on spectacular green displays in the last decade, and the chemistry was well understood.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
In this view, 3I Atlas was simply venting more exotic gases than most, producing an exaggerated version of a natural phenomenon. But the other camp could not ignore the pulse. Natural chemistry does not switch on and off with clockwork precision. Gas release may spike, jets may vary, but no comet ever recorded has changed color, and then timed those changes to subtle corrections in its flight path. To them, the glow looked less like chemistry and more like engineering. It looked like a system deliberately venting energy, perhaps even propellant, in a way that resembled a plasma drive or some other kind of advanced propulsion. 3I Atlas simply an extreme comet, venting cyanide and carbon in ways we had not yet measured? Or was it something designed, a craft shifting modes, changing its color because it was changing its function?
We cannot really pinpoint the nucleus size. It's partially due to the size of the object, but also it's partially due to the activity.
What the spectra revealed. If the sudden shift to green light unsettled astronomers, the deeper analysis of that light pushed unease into outright alarm. The James Webb Space Telescope is not only a camera, it is a laboratory orbiting in space, able to split faint streams of light into spectra, teasing apart the chemical fingerprints hidden in every glow.
The job is trying to unearth. It's all there. The universe is like sort of hiding in the darkness, and we have to bring it out.
When Webb turned this tool on 3I Atlas, the results stunned researchers who had expected the familiar signs of ice and dust. What they found instead was almost no trace of water vapor, the one ingredient that defines comets. For centuries, every comet seen by human eyes has been driven by the same simple process: water ice evaporating as it nears the sun, producing vapor, dust, and the familiar tail. It is so basic that textbooks describe comets as dirty snowballs, rocks mixed with frozen volatiles, lit up when heat releases them. But in the spectrum of 3I Atlas, the signature of water was nearly absent. In its place appeared a cocktail of gases and particles that did not belong to any known cometary model. Carbon dioxide registered strongly, far more than expected. Cyanide showed up in clear spikes, along with smaller traces of carbon monoxide. And strangest of all, clouds of nickel dust appeared, scattering the incoming light in ways that did not resemble natural ice grains. To the scientists reviewing the graphs, the mix looked less like nature and more like design. Some began whispering the obvious comparison.
The plume of gas around it is mostly carbon dioxide, 95% by mass, based on the Webb telescope data.
In experimental propulsion labs on Earth, engineers use plasma drives, systems that strip electrons from gases to create charged plasma, then hurl that plasma backward with magnetic or electric fields to generate thrust. Different gases produce different results. Carbon dioxide adds heavy mass for strong pushes. Cyanide conducts charge efficiently, allowing fields to grip it. Nickel particles stabilize the reaction and absorb punishing heat. The green glow of 3I Atlas matched almost perfectly the emissions seen when such gases are ionized under high-voltage arcs in laboratories. This was where the unease turned into a fracture. Those searching for natural explanations argued that exotic ices could exist in interstellar bodies. Perhaps 3I Atlas simply carried unusual chemistry from a faraway system, releasing carbon and cyanide instead of water. But others saw the combination as too precise, too convenient, and above all, too effective. It was not just strange gases, it was the right gases, the very mixture an engineer would choose if they were designing a plasma engine for efficiency and control. What deepened the terror was the way the spectrum tied back to the pulsing tail. Every burst of green light aligned with changes in trajectory.
Is that it's moving along a trajectory that is very special.
Every surge of cyanide or carbon emissions coincided with a nudge in velocity. It looked less like venting and more like a timed system, the way rocket engines burn in intervals to steer a spacecraft. In that rhythm, scientists saw not randomness, but intention. And yet, there was one last fact they could not ignore. Many comets have glowed green before, their cyanogen and diatomic carbon molecules lit up by ultraviolet light. Comet Lovejoy, blazing across skies in 2015, had turned an unmistakable green. So had 46 P/Wirtanen a few years later. The color itself could be natural, but no comet had ever pulsed. No comet had ever shifted its path with each glow. And none had carried the chemical blend that mirrored an engineer's toolkit so perfectly. If these chemicals were natural, then we had discovered a type of comet unknown to science, one that rewrote the rules of cometary chemistry. If they were not natural, then the green plume of 3I Atlas was not just a tail, but an exhaust, the product of an engine running in the dark. Both conclusions carried weight, and neither gave comfort. Signs of an engine, not a comet. By the time the pulses were measured in detail, even the most reserved astronomers began to admit that something about 3I Atlas no longer fit into natural categories.
It's easier for me to think this is a new kind of object that requires way more study than we've given it thus far.
Observatories tracking the object's brightness noticed that the green tail did not just flicker randomly, as one might expect from jets of gas bursting from the surface. Instead, it pulsed with mechanical precision, a heartbeat in the dark, repeating at intervals of exactly 232 seconds. Each time the glow peaked, the trajectory shifted ever so slightly, a nudge in speed or direction that could be plotted, predicted, and verified. Nature does not keep time with that kind of accuracy. Machines do. The implications were staggering. In spacecraft design, propulsion is never constant. Engines fire in bursts, conserving fuel and adjusting course through timed discharges of energy. The rhythm seen in 3I Atlas resembled exactly that kind of controlled system, and the fact that it was visible at interstellar scale shook those who analyzed the data.
That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
If this were simply ice venting, the timing would be irregular. If this were chemistry alone, the direction changes would scatter. But here, every flash and every motion aligned like clockwork. Speculation turned to the source of such power. At the heart of the pulses, scientists inferred must lie an energy system of extraordinary density. Calculations suggested an output near 10 gigawatts, an amount almost unimaginable for something only a few hundred meters across. To put this into perspective, the largest power plant on Earth, the Three Gorges Dam in China, generates about 22.5 gigawatts at peak. That facility spans miles of river, harnessing the force of an entire landscape. Yet here, in a compact body drifting through space, was an engine producing nearly half that power, over and over again, for weeks at a time. The contrast bordered on absurd. Human civilization builds colossal structures to reach such output. Whatever powered 3I Atlas fit inside a body smaller than many city blocks. Some researchers proposed that the nickel detected in its spectrum was not random debris, but part of this engine's architecture. Nickel is both dense and resilient, capable of withstanding high radiation and extreme heat. If the core of 3I Atlas were wrapped in a nickel shell, it could serve as both an engine block and a radiation shield, containing reactions hotter than the surface of a star, while protecting whatever advanced systems might lie inside. The idea was speculative, but it matched the data better than any comet model could. Dissenting voices tried to soften the conclusions. Perhaps exotic chemistry could mimic this rhythm. Perhaps coincidences in outgassing had tricked observers into thinking the object was maneuvering. But those explanations began to collapse when orbital data showed consistent deceleration, timed perfectly with the pulses. 3I Atlas was not just coasting through the solar system, it was actively adjusting its speed. For astronomers trained to trust natural laws, the sight was deeply unsettling. The sky is supposed to be predictable, a place where comets obey physics and orbits can be calculated centuries in advance. Now they were watching a body that glowed, pulsed, and shifted course as though it were under intelligent control. The term comet no longer fit. What they were seeing moved like a vessel. It moved like a machine. Orbital oddities and strategic movement. For centuries, comets have been trusted as predictable messengers of gravity and ice. Their orbits follow strict curves set by the pull of the sun and the laws that Newton first laid down. Nothing about them has ever suggested intent. They sweep in from the dark, flare as they near the sun, and then are flung back into space on a path that can be charted with simple equations. That is the order astronomers expect. And it was exactly why the motion of 3I Atlas became such a shock. In the first weeks after discovery, orbital data showed the object was traveling at more than 88,000 kilometers per hour. By itself, that was unremarkable. Interstellar visitors like Oumuamua and Borisov had moved at similar speeds as they cut through the solar system on open hyperbolic trajectories. But what happened next could not be explained by those models.
The trajectory is very well aligned with the planets, and it will come very close, as you pointed out, to Mars.
Within just 2 weeks, the velocity of 3I Atlas had fallen by roughly 1,000 kilometers per hour. To an ordinary comet, that is impossible. Nothing in space slows objects down unless they collide or are deliberately braked. Yet 3I Atlas was decelerating smoothly, without any visible cause other than the green pulses flashing behind it. Even stranger was the shape of its orbit. Rather than rushing past Earth in a simple flyby, the path seemed to bend in ways that kept it carefully away from our planet's line of sight. When orbital simulations were run forward, they showed the trajectory threading a path that would carry it close to Mars, then past Jupiter, with an accuracy that looked less like chance and more like calculation. To astronomers used to random wanderers, this avoidance felt deliberate, almost as if the object were following a plan. The evidence was not limited to a single observatory. In Chile, the Gemini South Telescope confirmed that the tail was not only growing longer, but also sprouting structures, a bright coma, an anti-tail pointing inward, and luminous strands twisting like braided cables. Other facilities watching from different hemispheres reported the same anomalies, ruling out local error or instrument noise. The consistency of the reports reinforced the sense that 3I Atlas was unlike any comet ever catalogued. To many, the idea of strategy could not be ignored. If 3I Atlas had been a natural fragment, its path would have mirrored the random scatter of Borisov, which raced straight through without slowing, or the odd drift of Oumuamua, which only hinted at non-gravitational acceleration. But here was an object that not only slowed down, but seemed to weave through the solar system as if choosing its course.
It is only the third time we have detected an object that has come from beyond our solar system.
Some called it the most disturbing orbital behavior ever recorded. Skeptics pushed back, pointing out that gravitational interactions with planets can sometimes produce strange bends in a trajectory. But those effects add speed rather than subtract it, and they cannot explain repeated deceleration paired with timed pulses of light. The odds of coincidence stacked higher and higher until even cautious scientists began to use words like mission-like when describing the object's path. The fear was not only what it was doing, but what it might do next. If 3I Atlas could alter its speed, then it was not bound to the passive arcs of gravity. It could, in theory, choose an orbit, slow itself further, and linger. The thought of an interstellar visitor no longer just passing by, but instead taking up a place between the orbits of Earth and Mars, unsettled astronomers more deeply than any glow or pulse of light. The hydrogen line signal. Light was not the only message coming from 3I Atlas. While telescopes studied the strange green glow, radio dishes on Earth began listening, sweeping across frequencies to catch any signal that might ride along with the plume. At first, the scans returned the usual hiss of cosmic noise, the background radiation of the universe, and the scattered chatter of natural emissions from the sun. But then, in sync with the pulses of light, something new appeared. A tone, a hum, a signal at precisely 1,420 megahertz. 1,420 megahertz is known as the hydrogen line. It is the frequency emitted when neutral hydrogen atoms, the most abundant atoms in the universe, switch their electron spin state. It is universal, clean, and recognizable everywhere, from the Milky Way to distant galaxies. For decades, the SETI program had chosen this frequency as the primary channel to search for extraterrestrial signals, calling it the watering hole of the cosmos. The logic was simple. If any intelligent civilization wanted to announce itself, it would use the hydrogen line, because everyone with a radio telescope would be listening. And now, with 3I Atlas, something was transmitting on that exact line.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
The discovery was more than coincidence. Each time the green plume brightened, the hydrogen line signal surged, as though the two were linked parts of a single system. Brightness, thrust, and radio all pulsed together with the same rhythm of 232 seconds. Engineers familiar with transmitters noted that the pattern looked structured, not random static, but something produced by a cycling power source, perhaps even a form of communication. To others, it seemed like the byproduct of an enormous energy system, the natural spillover of a reactor or propulsion core, powerful enough to bleed into the hydrogen spectrum. What made this terrifying was not only the existence of the signal, but its nature. Ordinary comets do not hum at 1,442 megahertz. No cloud of cyanide or carbon dioxide produces structured radio bursts that rise and fall in perfect time with visible light. To hear such a tone from an object already glowing unnaturally and steering itself through the solar system raised a possibility too stark to ignore. Either 3I Atlas was carrying a transmitter, or its propulsion system itself doubled as one. In both cases, it meant technology. The SETI community, which had spent decades scanning the skies with no confirmed detection, suddenly found itself staring at the very signal it had always predicted. Weak but steady, repeating but not chaotic, the hydrogen line was no longer an abstract dream. It was being broadcast, however unintentionally, from an interstellar body within our solar system. Scientists debated the implications furiously. If it was deliberate, then 3I Atlas might be announcing itself, pinging every world within range of its exhaust. If it was accidental, then the signal was a leak, proof of a machine so powerful that even its waste energy echoed on the most universal frequency known to physics. Either explanation unsettled astronomers, because natural or artificial, chance or design, the hydrogen line is not where comets live. The threat to Earth's space systems. Until this point, the strangeness of 3I Atlas had been something astronomers could watch with a certain detachment. A glowing tail, a pulsing trajectory.
NASA scientists first spotting 3I Atlas in July, just a tiny speck of light sailing through a sea of stars.
Even a radio hum at the hydrogen line. These were phenomena unfolding millions of kilometers away, distant curiosities to be studied with telescopes and debated in journals. But as the data from the plume became clearer, a more immediate danger emerged. The green exhaust was not just light, it was matter. And what that matter could do to Earth's fragile space infrastructure was terrifying. When Webb split the tail into its spectral parts, it revealed a storm of particles, cyanide ions, carbon gases, and clouds of nickel dust. On their own, these might not seem unusual for an interstellar body, but at the densities measured and in the patterns observed, they represented something unprecedented. Unlike solar wind, which flows as diffuse protons and electrons, the plume of 3I Atlas carried heavy, charged particles in concentrated bursts. Each pulse was not a soft glow drifting harmlessly into space. It was a shock wave of chemical and metallic debris, accelerated by fields strong enough to alter the course of the entire object. For satellites orbiting Earth, this was no minor concern. Modern spacecraft are hardened against solar storms, bursts of radiation and plasma from the sun, but they are not designed to survive direct streams of exotic exhaust. Solar panels, built to convert light into power, could be fried instantly by cyanide-rich plasma cutting through their circuits. Nickel particles, moving at interplanetary speeds, would behave like shrapnel, puncturing thin hulls and scattering electronic systems. Antennas designed to receive weak signals from the ground could short-circuit under the assault of charged clouds sweeping past. Earth has already suffered from smaller natural events. In March 1989, a solar storm injected enough charged particles into the planet's magnetic field to collapse the Quebec power grid, leaving millions in the dark. Satellites have been lost before to radiation storms, their circuits silently fried by invisible currents. And those were natural outbursts from our own star, diffused by distance and atmosphere. What 3I Atlas carried was more focused, more violent, and potentially directed. If its exhaust intersected Earth's orbital path, the effect on satellites, navigation systems, and communications could be catastrophic. NASA quietly drafted the first emergency protocols in history for dealing with an interstellar object as a direct threat. The concern was not impact. The body itself was still on a path that avoided Earth, but contamination of orbital space. If even a fraction of the green plume swept across the region where thousands of satellites circle, the results could resemble a technological blackout. GPS signals, weather forecasting, international communications, even basic internet connectivity could collapse in a matter of hours. The global economy, so reliant on satellites for timing and navigation, would feel the shock instantly. What unsettled experts most was how little could be done. Satellites cannot be recalled. They cannot be shielded at scale. If 3I Atlas carried a plume capable of sweeping through Earth's orbit, then humanity's eyes, ears, and digital arteries in space would be exposed with no defense. The green glow that astronomers first marveled at now looked less like a mystery of nature and more like a hazard spreading across the solar system. For the first time, the question was not just what 3I Atlas was, but what it could do to us. NASA's response: the Juno 1 probe. Astronomers could argue about chemistry or engineering, about whether 3I Atlas was a comet or a craft, but the reality was simple. Its behavior was unprecedented.
It's partially due to the size of the object, but also it's partially due to the activity, and so we cannot really pinpoint.
And its exhaust posed real danger to the satellites and systems that Earth depends on. Watching from the ground was no longer enough. For the first time in history, space agencies began drafting plans not for a distant probe decades in the making, but for a rapid mission designed to meet a threat head-on. The name chosen was Juno 1. The mission brief was bold to the point of recklessness. Juno INS would not orbit, observe, or linger at a safe distance. It would dive straight into the green tail of 3I Atlas, a maneuver so hazardous that some engineers compared it to flying into the exhaust of a rocket engine running at full throttle. But there was no other way to know what humanity was facing. Designing such a craft on a crash schedule required compromises and innovations. The hull would be plated with a ceramic nickel alloy, built to endure the storm of cyanide ions and metallic dust that ordinary spacecraft materials would never survive. Inside, every instrument would be hardened against radiation, with redundant systems to preserve data, even if the probe itself was destroyed. Cameras would be sealed behind reinforced shields, programmed to snap images of the plume and the core.
From images, we also saw that this object is active, which means that around the nucleus there is some coma.
Juno 1 was not expected to come back. It was expected to last just long enough to send its readings home. For the engineers building it, the challenge was unlike anything attempted before. Missions such as ESA's Rosetta had spent a decade carefully rendezvousing with Comet, mapping its surface in gentle arcs. NASA's DART mission had slammed into an asteroid to test planetary defense, but it had targeted inert rock, not a living stream of plasma. Juno 1 would be the first spacecraft ever sent to pierce the active exhaust of an interstellar object, a place where every pulse carried gigawatts of energy and temperatures hotter than a star's surface. The gamble was obvious, but so were the stakes. Without direct measurements, the world would remain blind. Was 3I Atlas venting strange chemistry, or was it firing an engine older and more advanced than anything humanity had built? Was the hydrogen line hum a deliberate transmission, or only the leak of a colossal power grid? The answers lay hidden in the green light, and Juno 1 was the only hope of finding them before the object passed too far from reach. As construction began, astronomers admitted what only months before they would never have said aloud. Humanity was preparing to approach, for the first time, what might be an alien drive system, still burning, still active, still writing its trail of green fire across the solar system. Whether Juno 1 survived or not, the attempt itself marked a turning point. We were no longer just watching. We were stepping forward. What happens next? Even as engineers rushed to assemble Juno 1, the object itself continued to evolve, forcing astronomers to admit that they were watching something dynamic, something that was changing before their eyes.
The more data we get, the better we can measure the position of this object as it travels through the solar system and it moves.
Night after night, amateur astronomers with modest telescopes began reporting strange flashes in the green plume, faint but rhythmic, like Morse code written across the sky. At first, these were dismissed as camera artifacts or the limits of small optics, but larger observatories soon confirmed them. The flashes were real, threading through the plume in braided strands that twisted and untwisted as though magnetic fields were shaping them. What disturbed researchers most was the consistency of the central glow. No matter how long exposures ran, the bright point at the core stayed sharp, refusing to smear into the soft halo expected from dust and gas. Instead, it burned, as if the camouflage of the plume was thinning just enough to reveal the engine beneath. The thought unsettled those who had argued for natural explanations. Comets blur, but this object did not. It looked, increasingly, like a system built to conceal and reveal in phases. If the red and yellow stage had been a warm-up and the green phase represented a higher energy mode, then the next shift might push 3I Atlas into something more powerful still. Theories circulated that the glow could soon turn blue-white, the color of ultra-hot plasma, the kind of discharge seen when engines throttle to maximum thrust. If that happened, it would not just brighten, it would maneuver decisively. Some models suggested it could slow even further, entering a bound orbit instead of escaping. The most unnerving projections placed that orbit between Earth and Mars, a place from which it would not vanish but remain. The possibility of a deliberate slowdown cut deep into the scientific community. Interstellar objects are supposed to be brief visitors. Oumuamua had swept by in months, Borisov in weeks, both gone before humanity could launch so much as a probe. But 3I Atlas was different. If it stayed, it would be the first machine from another star to take up residence in our neighborhood, a presence not passing through but remaining, watching, perhaps even waiting. Every new observation layered the tension higher. The hydrogen line hum persisted, rising and falling with each pulse of light. The orbital path bent in ways that looked less like drift and more like selection. And the plume itself seemed to grow denser as it drew closer to the sun, not dispersing, but concentrating, as though feeding on the star's field to amplify its thrust. The data piled up into a narrative no one wanted to say out loud, but everyone understood. 3I Atlas was not done changing. The green glow was only the middle of a sequence. The existential question. If 3I Atlas is a comet, then it is unlike any comet ever seen. It violates the rules of physics that have been confirmed across centuries of observation. And its chemistry, stripped bare by Webb's spectrum, matches not dirty ice, but engineered fuel. To call such a thing natural is to admit that nature itself still hides forces we cannot account for, processes powerful enough to mimic engines and mimic signals, and to accept that the laws we teach to every new generation are incomplete. If, on the other hand, 3I Atlas is not natural, then the implications are heavier still. It would mean that humanity is no longer alone in the practical sense. We would not just be debating the possibility of alien life, but watching the active presence of alien technology, maneuvering inside our solar system in real time. That presence is not a message sent across light years, not a relic dug from ancient rock, but a machine, alive and running, built by hands or minds not our own, and close enough that its exhaust could touch our world. To confront that is to confront the idea that we are already in contact. The green glow is more than light. It's a signal of the fragile line between what we think we know and what we fear may be true. For the first time, humanity is staring at an interstellar machine that changes color and steers with precision through the inner solar system. The existential question is not whether it is natural or artificial, comet or craft. The question is whether we are prepared for the answers we keep seeking.